Thank you, Clay, for the introduction. Thank you very much. Okay, gentlemen, I really appreciate your time and effort to attend to this conversation. Basically, I am Santiago Mujica. I work for Exxon, BP, and Equion Energy. Nowadays, I'm working for PetroSkills as a subject matter expert on completions and integrity. I prepared this presentation. It's an introduction about the whole well integrity process. That we have also another training courses virtual for this matter. Okay, so basically here we have our presentation, and this is the legal part of this. Basically, is some PetroSkills imply some no guarantees about certain issues. Okay. However, okay, the agenda. Let's talk about the well integrity. We are going to talk about the industry documents that we have available to be in compliance with the well integrity. Then we'll go to the why is the well integrity management process required? That is the main subject here today. Then we are talking about what are the possible causes that you have for the well integrity issues. We speak a little bit about well barriers, and then we go to the what are the some risks during the well constructions and the consequences. Okay, so talking about well integrity, the first thing that we need to talk about well integrity is what is integrity? Is if you see this picture, we can see that there is a loss of control of the well. The well is flowing, in this case, is gas at about 50 million gas per day. We lose the control in a well intervention, and there was a problem that we experienced in that operation. So basically, the well integrity is how we apply all the technical, operational, and methods, organizational methods to prevent and control fluid to surface, or sometimes subsurface flowing to other formations in the wells. Okay, what could be? What do you need to have in place for this to prevent these events? Basically, you need policies, processes, standards, assurance, and procedures. So there are a lot of documents and information that we need to have in our organization to prevent these issues, okay? This is the Deepwater Macondo. This was the Deepwater Horizon, the rig in the Gulf of Mexico in 2010. That was a rig, that the semi-sub rig that was used to drill the Macondo well. And then we have an well integrity issue in the completion phase at the end of the construction. Because of that issue, we have explosion. The well was out of control. We have explosion. Then we have trying to protect people. There was people injured. There was people killed, and then we have a big oil spill. So this is the more drastic event that we have experienced in the industry nowadays, but we could have similar problems. So what we are trying to do is, I would like to introduce you, is to see how we can manage this, how we can prevent this. So in the industry documents, we have many documents for compliance. So the most important one that we normally have as an operator is the well integrity management system. That document is the document that we use to prevent and to maintain the wells for the life of well cycle. So in that document, you need to include all the organizational structure, risk, barriers criteria, barriers verification, management of change process, reports, standards, and continuous improvement process in there, and when you need to do some audits into the system. Okay, so this is well integrity management is a key document that all the companies, I recommend to all the companies to have in place. Okay, the most important document as a company is to have a policy. The well integrity policy is to cover from top down all the issues regarding to the HSE, to the operations, and to the management of the well integrity. Okay. This document is under this document you have the well integrity management system. Also, you have a lot of information that you can get from the industry that they have developed. But we have a lot of normatives. One of the most important one was the petroleum and natural gas industry, the ISO 16531, and the NORSOC. And we have plenty of those documents to cover different things like annular pressure management, deepwater design, construction analysis, and let's say for downhole safety valves. So we have a lot of normative documents as a reference to prepare my well integrity policy, my well integrity management system, and also to keep that as part of the policy for the company. Okay. No. Okay. Now, why is the well integrity management process required or important? So, based on the ISO 16531, these are the phases that they consider that we need as a company to have. So, from the basis of design phase, then the design phase, the construction phase that is the drilling site, then we hand over this into operational people. We do some interventions and then have the P&A. Okay, this process is very solid. I like this process because it includes all the areas that we need to have in the well integrity, in the life of well cycle. Also, we have here the lesson learned. So we always learn from the operations, learn from the intervention, and from the process itself, okay? So we need to feedback all these and learn and apply for the next well. So we are really in a development plan. We are doing a development plan. So every time that we do the well, we can learn from that and we can fit the basis of design or the design phase for that well, for the next well, and so on, okay? Using the different documents that the company should have in place, okay? I'm going to talk about basis from that process, from the ISO. I'm going to take the basis of design, but for the input requirements. So why? These basis of design documents, I consider this one of the most important documents because every time we develop a field, we are going to develop a field, we need to have very clear what are the well objectives, what kind of data we need to have, what consideration we need to have through the life of the well cycle, okay? What kind of fluid parameters do we need to consider? What kind of interventions we are going to do it? What is the strategy for management, for maintenance, for testing the wells, for testing the Christmas trees, and so on? So this basis of design document is quite important to have it. And we use that for every well design and so on, okay? Based on that, how do I build the basis of design document and my integrity management system? So we need to start from scratch. Let's say we have a field, but we are going to do an exploration well. In this case, an exploration well. So from the exploration well, we obtain some data at the beginning, right? From the exploration wells and the appraisal wells, we have data. We collect information from fluid, from the rock, okay? And we analyze the productivity, the GOR, and things like that on that moment. We collect some information like PVT data. We develop, we simulate the well behaviors, the reservoir field behavior, and then the reservoir guys built the production forecast for that field, right? So we can see from the PVT and some simulation studies, we can start building a field development plan where we can see maybe we'll have some information from the water, maybe not. And at the beginning, we consider those kind of factors, okay? From that, once we build that, we have the initial production, we define the twin size, the number, we say we are going to drill, let's say 30 wells, 40 wells, and so on, okay? What kind of, that field needs artificial lift or not? what is the development plan to build and maintain the plateau. Then we said, okay, we are going to perforate the zones, and we are going to do, let's say, cold twin interventions, or we are going to perforate the zones, the reservoir by doing E-line, slick line, and maybe we can plan in advance from the beginning what kind of workovers we are going to need. So we need to plan that in advance just to see what kind of size of the tubing, what kind of damage of the tubing we'll have because of, let's say, cold twin runs, E-line runs, or whatever, okay? Once we have the water composition also, if we are lucky, we get from the appraisal well, the water characteristics, we can, and the fluid characteristics we already have, we can simulate what kind of corrosion, erosion problems we will have, if we have some production or not. So all those considerations are quite important for the completion, for the casing sites and completion sites. That's very important. At the end, once we plan the completion, also we normally consider the most important part is how we are going to spend on P&A. So all that information from the beginning, that's what I talk about the BOD. BOD is accompanied by this kind of planning, and those are the things that we need to know. Okay, very important phase, this one. Okay, this is the summary of the life of well cycle. The main point here is, okay, once you define the let's say, basis of design, drilling and completion, production, intervention, suspension, we need to have, as I said, some lesson learned collection every time we drill a well, and some key performance indicators to know how we are doing. Those things always in drilling and completions and other operations, we always have some risk to include. So we need to consider risk, and we need to have all digital to ensure that all the information is collected. So when we talk about policies now, what is my recommendation for the operator for DSNI? Normally, we need to have the engineering, the policies, we have engineering practices, well requirements programs to support the different areas that we consider in the well. Like program definition could be DSNI program, what kind of G&G or geological things we have in the field. We are planning to do any stimulation work, so what kind of fluids we are going to use. So we need to consider that as part of the, it's a special program for stimulation or fracturing, what kind of corrosion we have or could have, okay? And we need to define a strategy for these kind of things, okay? For the different phases. So we have to work this from bottom to top. So once we have all the clarity on the programs, we can see how we are going to do the operations, okay? Very important, as I mentioned, is we need always risk in the drilling phase or completion phase or the intervention phase. So always it's important to have a risk matrix in which we define what kind of risk we will have. For example, in drilling, we have a high deviation wells, horizontal wells, so we need to consider the risks. Because of that, we need to define exactly what problems we are going to have in the well, okay? All those things are supported by the methodology that normally you have. Every company has a methodology for a risk evaluation, and we will talk that later. And then we need to keep risk report and ranking of all the problems that we have. My recommendation for you guys is to have, because normally a company have drilling and completion department, then the operations or production people, interventions, and this is the phase that is normally included here. But I will include always this area that some people has to be focused on within the basis of design to update the conditions of the well, okay? As a company, you need to have a well integrity strategy, you know? What is the integrity strategy? The integrity strategy is all those programs and procedures that we need to, that we need to consider to deliver wells according to the minimum integrity requirements. Or in other words, we will try always to have the well with a very good integrity. Sometimes you could have some issues, but then we need to manage those, okay? Excuse me. So now, all that, I include field manager, but you can have here the drilling and completions manager. I don't know, depending on the company, you have some people that is that they're responsible and accountable for this specific issue, well integrity. Then you need to define technical authorities in different areas. For example, casing design, a technical authority for casing design, a technical authority for completions, a technical authority for interventions. That's the ideal. Just to have people who really knows and has experience on those areas, okay? And those that strategy should be supported by the minimum requirements, as I mentioned, lesson learned. You need to have a very strong management of change process, because sometimes we change process and we have problems. If we don't collect this properly and we do not evaluate, if we don't evaluate properly, when we are making changes in drilling a well, let's say, we could have some bigger problems that we have at that moment, okay? I include here the well dispensation documents. I put it on red because normally those dispensations has been the most critical documents that you can prepare, because dispensation is to postpone some, let's say we are going to postpone some integrity fixed. We are going to fix, let's say, bypass some part of the facilities. We are going to, let's say, dispensate because the well has a annular pressure, very high annular pressure. So we dispensate for a period of time while we are bringing the rig. But if we don't do that, on time, that dispensation is dangerous, because we signed it, we say, yes, we can do it up to this point. If we then extend that dispensation, then the pressure could increase, and then you will have bigger problems. So be careful with the dispensation documents. They are good. We postpone because we don't have the rig at that moment, but in 2 or 3 weeks, when a month, we have to fix that problem, okay? Talking about risk, we recommend, I put risk management, risk matrix, and things like that. You always need to have a risk matrix about the wells. Let's say you have 100 wells. Maybe you have more than that. So you need to have clarity on the risk for every well, because you don't know how to manage sometimes. If you don't know what are the risks, you don't know how to manage those. And those are the surprises that you could have in integrity, okay? Also, you need to have operational procedures and standards, and safety critical equipment records. Safety critical equipment, we'll talk about that. And this is quite important to have, because now we have HSE, so all the policy is on HSE. We have the well integrity management system. We have policy for drilling. And also we need to have that supported by procedures, programs, standard, and practice, okay? So that well integrity strategy is supported by different documents, okay? Those documents are prepared specific for that field. If you have another field, you need to create, because you can have some changes into that, okay? So you cannot standardize to the whole, to different fields all the times, okay? So, or include criteria. For this field A, I have this procedure. For this field B, I have the other one, okay? So pretty important that. One of the things that normally we need to have is very good clarity on the roles and responsibilities. When we talk about technical authorities, also we talk about people. Always people is managing the wells. Always people is taking the decisions. So I put here some different activities and different positions. So let's talk about a few. So the well integrity engineer is the responsible for most of the issues related, okay, all the issues related to well integrity. But that guy has to be, needs to have in cementing design and operations, is to have at least an intermediate level, you know. In the evaluation of the microfinger caliper logs and UC logs, she should be an expert. So we need to define what kind of expertise each person should have and what kind of responsibility it should have. So he has to be almost the well integrity is a person who really needs to know like integrated knowledge on many things. But let's talk about a well pad supervisor, well pad production operator. That guy, maybe in cementing operations, just the awareness about the quality of cement. We need cement. This is the things that we understand for the well. These are the liner, the production casing. Okay, but in the annular pressure investigation, he should be an expert, right? And in the well test, Christmas tree and downhole safety well test, he has to be an expert. So we need to specify, depending on the position, we need to specify what kind of responsibility and role that each position should have, okay? Now, let's change a little bit the subject. What the possible cause of the well integrity is, okay? So, what are the variables? I have a well here, very simple well, is not with a completion equipment yet, but what are the variables we have? We have pressure, temperature, and energy. We always talk about pressures, you know, annular pressures. We have temperature profiles. We have changing pressure, annular pressure changes because of the temperature changes, okay? And energy, that it could be some formations that are over pressure. So we have all those factors. Normally we talk about these factors, but there are other factors very important in well integrity, in variables integrity. People who make the decisions. The decisions are made by us, by people. For example, in a well intervention, the well intervention engineer made the decision. You can have a very good procedure, but who is making the decisions at the rig site? Who pressure tests the equipment? Us. So who made the decision about the leak, if the pressure test is fine or not? So people, that's why we talk about roles and responsibilities and competencies. So we need people with competence to make decisions on well integrity, okay? Equipment. When we talk about the equipment, we select equipment based on corrosion, erosion, pressures that we are going to apply, and let's say the connections and things like that. So we decide what kind of equipment we are going to run. So it's not only the pressure and the temperature, sometimes it's the equipment. If the equipment is not designed properly, we make mistakes in the well. Then we'll see that when we'll see the problems. Procedures. As I mentioned, if we are doing let's say a cementing operation, if I don't follow the procedures, maybe the cementing operation is not good. So how we ensure we are following the procedures and standards. We can have standards, standardized procedures, standards for following our operations. So all are the things that we need to keep it. It's not only that is related to pressure, temperature, and energy. It's related to people or other stuff. Okay. We mentioned safety critical equipment. One of the most important things in the wells is what is the critical equipment that we install in the wells. So we have a wellhead, we have the casings, what production casings, production liner, packers, tubing, downhole safety valve, Christmas trees, and maybe other tools. But what is safety critical equipment? Is all that equipment, let's say, let's do an example, production packer. Is equipment that we need to ensure has all the capability to support the burst pressures, the collapse pressures. The rubber element is designed for the fluids that we are going to work with, or the stimulation fluids that we are going to pump into the well. Also, maybe the temperatures that we are going to set that packer. Also, the stresses and the loads that we are going to apply onto this production packer. So there are many factors that we need to consider for this, the selection of the packer, and that's why we call safety critical equipment, because if the packer fell, we are going to have leaks in the well from the internal to the annulus, and maybe the annulus to the B. So that's what we define as a critical equipment, okay? Safety critical equipment. Wait, let's say we have this kind of equipment in a well. So we have many pieces of the equipment in the well, right? the first question as a completion engineer that you have to, or as operation engineer, you need to identify what kind of equipment I'm using, okay? Do we really need that equipment? What is the piece of equipment for? Do we really need to, let's say, this is a slide in a clip, do we really need that slide in a clip? Are we going to operate that? How many times we are going to operate that? When we are going to do it? Sometimes we include tools or pieces of equipment that we don't need it. So the less equipment that you run it, the less problems, you are going to reduce the problems in the well, okay? Where are the leaks? For the same well, where are the leak points here? All these leak points, right? So look at the points that you can have a leak. Let's say you have a well at 10,000 feet, and the casing is 40 feet long, each joint. So how many joints you have? 250. So every connection we have a possibility of the leak, right? So we need to ensure connections, the design of the connections of that casing, if the casing support the loads, if this casing is designed for gas or not. Is a premium connection or not? Do we need a premium connection? How we are going to cement that? What are the possibilities to have a failure on the cement? Talking about the tubing, do we really design the tubing for the loads that we are going to have? Maybe yes, maybe not. So we need to design and simulate that tubing for that. Do we apply the proper dope on that? Okay. Do we need? I mentioned the circulating slip. That circulating slip is the right material. When we talk about tubing and casing, do you have, let's say, CO2 or H2S? Do we really have the proper metallurgy for this tubing? If not, we are going to have corrosion. Then you have very soon, if you have water, you are going to have leaks through the tubing or to the casing. If you use downhole safety valve, what kind of safety valve we need? What kind of, what is the maximum depth we should run it? If this is subsea, we need to consider what kind of fluid we are going to put in that control line. Okay, now in the wellhead, normally the company, sometimes they sell to the service company, sell to you a lot of valves. So do we need in the section A, B, and C only one side outlet valve, or we need two side outlet valves? You have a problem in the annular, maybe we need two side outlet valves. The Christmas tree. What about the twin head adapter? The twin head adapter is a corrosion designed for corrosion. How is the primary seal? Is metal to metal or is it an elastomer? Do we really need a primary and secondary seal? All those kind of considerations we need to have in mind always when we are designing wells, okay? Let's talk about barriers. People talk about barriers. So we have a different type of barriers, okay? We have mechanical barriers, operational barriers, human barriers, administrative barriers. Okay, what is the meaning of barrier? It's a combination of competent practices that contribute to the reliability of the system to prevent, keep control of undesirable fluids to surface or downhole. So anyway, a barrier is something that we run into the well to prevent or to maintain the pressure that is designed for. Okay, we have mechanical barriers like plugs, maybe linear top packers or production packers, and we have operational barriers. There are procedures in place. Okay, there are human barriers because sometimes, as mentioned before, sometimes the human barriers, a person will say, no, this is fine, and it's a human barrier. Or you say, no, we have to pressure test properly. We have administrative barriers. So sometimes what we say to management, they normally, maybe they are going to make a decision. So there are some kind of administrative barriers in the decision. So what is this? Sometimes you say, as an engineer, we need two barriers. And some people say, no, one is enough. Let's pressure test to the maximum water pressure. No, let's pressure to do 2,000 PSI. So those are kind of things, human barriers, administrative barriers. So be careful with that. Always you make, as an engineer, you have to make calculations. The number of barriers, always we talk about, we recommend primary and secondary barrier. So normally you design for a primary, that is a typical barrier that maintains the source of the pressure, okay? Sometimes the secondary barrier has the same, let's say, the same qualification or the same composition to protect that, because sometimes that primary barrier fails, that's going to be, that pressure is going to be applied to the secondary. So depending on your criteria and the needs from the well, the pressures and the fluids, the type of barrier for the primary could be the same as the secondary or very similar, okay? So that's a criteria. In this example, I have the blue one is the primary, so we isolate, this is a P&A, so we pump cement, we isolate all the perforations, we cover above the perforations, we have very good cement behind this, all right? So also we have the secondary barrier, we have a liner top packer here, right? We have a casing, we set a second plug, so we have primary and secondary barriers to prevent any fluids in the future. When you P&A, you need to ensure you have a proper insulation, okay? Now, how those barriers should be verified. So normally we do functional tests. Those functional tests are done externally, I mean, before you run into the well. So let's say a packer has been tested in the shop. Then once you pressure test it and verify the packer is fine or the plug is fine, so then you do a pressure test verification at the well itself. So normally the recommendation is to pressure test in both directions. So you can do a positive test and sometimes a drawdown test if this is possible, okay? And you need to consider all the temperature effects and conditions. But remember, a barrier that you run in the well has to be, is a safety critical equipment, because if you are going to say for permanent isolation, you need to verify that this is going to work for a long period of time, okay? And these are the performance criteria for different barriers. So every time, as I mentioned, is you have, let's say, a packer or plugs. So you need to know how that packer is going to behave with time through running many times with the wireline operations, or what kind of a specification for boards and collapse. Then you need to, run to perform a connection test, material test, functional test, test duration. All those things depend on the criticality of the equipment in the well, okay? But always you need to have a minimum considerations to control that, okay? A little bit about tune retrial safety valves, wireline retrial safety valves. So depending on the requirements and the well type, you can have wireline retrial or tune retrial. This depends on many variables, If I need to, every time, for example, that I run a wireline retrial safety valve, I need to put it out, and do the operations, and then I have to run in back the valve. But every time that this profile or the seals are exposed to operations, you have the risk of damaging those seals. So maybe you will damage that. So that criteria always depends on the operational side, and also based on the operational side, because so you have so many wireline, E-line, coiled tubing operations, there is a high risk of damaging that profile. And the other thing that may affect or push you to make that decision is the size of the production case. If you don't have enough space to run a tubing retrial, then you have to run this wireline retrial, okay? But I recommend always the tubing retrial, because then you have the option. If you damage that valve, you have the option to do a troubleshooting and run and leave it as a wireline retrial safety valve afterwards, after the damage, okay? These are the API. Everybody knows these are rules. Everywhere, there is a recommendation to pressure test the downhole safety valve at least twice a year, or every 6 months, I mean, okay? Let's talk about a little bit of risk, and we talk about processes, about some barriers and issues. Now talk about some risk during construction. What is one of the most critical barriers in the well? Our cement. Cementing operations are the most important things to have a proper isolation, to prevent leakages, isolate zones, production zones, or between other, let's say, abnormal pressures, okay? So this is a nice cement operation where you have 100% cement. And I have example about this, no cement, or maybe partially cement. For me, this is the same. You don't have cement, you have you don't have isolation. So you don't have a good centralization and you don't have a good 360-degree isolation in the casing or the liner, you don't have good cement anyway. Some people, they, no, this is more or less, no. Or you have isolation or you don't have isolation. What are the reasons? This is a statistic. For example, what is the key for the cementing operation? The job planning, you can have 30 or 35% of that. All the planning of the operations, okay? Let's say the design of the cement, the length of the cement, and the pumping rates. Then the spacer design is 25% of the success. Then the type of cement is 15%. And then operational problems are 20, and other reasons are 10. So if you see, for example, this is quite important. 70% of the problems that you have in the wells is because you failure to do something on this. So in other words, the planning phase is the key factor to be successful in cementing operation. We have, in the other training course that I have, I speak about a lot of things about job planning, spacer design, and slurry design. But you see, 70% of this, or minimum 60 to 70% of this, is the planning. Planning phase is the key. What kind of cement you have here? As an example, before, in the previous, you see we have a partial cement. This is the bond index, so you have communications between zones, so you don't have a good cement job. Maybe this is a contaminated cement. Seems to be, and it's in one side of the casing, you know. Also, you didn't centralize properly, and you have this varying through the 360 degrees. What are the problems when you have these kind of issues? Then you have, what happened? You don't have the previous slide. Maybe you have loss of circulation, maybe you have premature returns, maybe you have problems with the spacers. So at the end, based on different problems that because of planning, because of pumping rates or whatever, then you have water zones producing, contaminating the oil zones, so you lose the production of the well. And remember, the water comes pretty easy, so the production, the oil production will be highly deteriorated because of problems with cement. So cement operation is a critical factor for success in the well, especially, I would say, in production, in the production liners and production cases, okay? And there are so many more factors that we induce when you are doing the cementing operation. Later on, when you have these issues on lack of isolation or zonal isolation problems, then you have pressure in the annulus. Then we need to start talking to the well integrity engineer and production guys and say, okay, guys, we have a problem. We have 1,000 psi in the annulus. So then we have to set up upper limit. So we need to know exactly what kind of pressure we are going to need to manage this, not to have problems downhole. Maybe we'll have pressures higher than the equipment that we have installed in the well. So then you start having, so you need to start concentrating on managing the problems on the angle. So you need to have, normally the maximum annular surface pressure is 80%, is a rule of thumb, is 80% of the max, okay? This is not ideal. but we have many wells. That's real life. Sometimes it's very difficult to manage, so we'll need to survive with that, but we need to know exactly what we have at surface and what we have downhole to prevent, let's say, problems in the well, okay? These conditions basically are in the wells. Let's say when you are drilling a well, we have other problems, you know. Why we have those problems on cementing operations? Sometimes they say directional profile, we change directional profile, and now directional profile do not allow you to have a good cementing operations. Maybe you have a formation, unstable formation, and you have hole stability problems. Then you cannot get the casing to the bottom, so you are lack of cement, or you pump the cement operation and you have contaminated cement. As a consequence, we don't have zonal isolation. Maybe you have water influx or gas influx, the worst case scenario. We have some wells in BP, Colombia, where we have a zone that was water influx, but it's still a problem because they get sometimes too high pressures. But when we have gas in the annulus, that's a different problem. If the gas is only gas, but if you have H2S, let's say in the Middle East, and you have a lot of H2S, it's complicated. Other issue that is very common is a casing wear. We design wells for a certain pressures, right, in the casing design. But let's say this production casing is 95 inches casing, and then while we are drilling the lower section, we spend so many hours. And this rotating, if we don't have protection to the casing protectors, I mean, drill pipe protectors, then we'll damage the casing and we generate the casing wear. If this casing wear is high, then you could have big problems in this production casing on production, okay? So casing wear is a key factor on the integrity. Liner laps. Now, I put here a liner lap that is without any liner top packers or liner hangers. Let's say we normally run liner hangers. And let's say you don't run liner top packer. Maybe you have influx from the formation because of lack of cement here. So gas is coming to the annulus, okay? In the completion side, let's move a little bit. In the completion side, once you run the completion, you pressure test the completion. You can, you don't have good cement, you can pressure test the completion, and the completion failed to fail the integrity test. So be careful with this. Sometimes happens. Then when you put on production, you'll see the gas coming into the annulus. Then you have this, another problem that we normally have is corrosion, erosion. Depending on the fluid, we need to design the completion tubing considering those issues. Do you have paraffin scale problems or whatever? At the end, we talk about the maximum pressures in the end. So there are so many different issues here. I like this diagram because this is something that I saw during my work experience when we were drilling a well. There was a field around this well. There was a gas injector well close by, and also oil producers. And when we were drilling the well, we have a kick. We have to shut the well in, do the well control process, and unfortunately, we believe that was we say that we shouldn't have this problem, but that problem comes from another well that we have some integrity issues, no cement, and the gas injection well was moving downhole, and we have to abandon this well. Why? Because we have an integrity problem in other wells. Okay, you have to be very careful with that. Also, you can have this communication through the other sections, in upper sections. You see? So this is quite good example, and it's real. It is happening. It happened to me. Okay, when then we talk about in all the fields, most of the fields, no, but in most of the fields we talk about sustained cane pressure. And we say cement quality, casing liner leaking. We say no, this is a completion equipment leaking, tubing leaking, sliding slip failures, other causes. Okay, and how we control, how we manage those? Pressure management. Most of the time, we have to manage the pressure at surface. We fix leaks. Sometimes we have the ability to fix leaks, let's say in the tubing, because of the connection leak. We bleed pressure, so we can install continuous with special procedures, prepare management procedures, and we do still to manage bleed off pressure, automatic bleed off pressure sources could be an option. Sometimes we need to perform workover. In the worst case scenario, it's a P&A. So we need to look to prevent these problems, okay? Working on these issues, going back to the design and so on, okay? What is something that happened in, I have seen at least 3 times this problem. It's a well shut it in for a period of time. The well cooled down, everything is cool. Then the operator come to the well. They say, okay, we need those 50 barrels that we have in well number 100. So that the operator goes to the well. The well has A, B, and C annulus pressure. He opens the well and what happened? Temperature increase as you go put on production. Then when you put on production, the annulus pressure start heating up. The fluids expand. When the fluids expand, increase the pressure, and the pressure blow out the surface wellhead. Why? Because liquids expand they have a lot of high expansion increment because pressure more than the gas. The gas compress, so you don't have that effect, that sudden effect. You will have, but not as with liquids. So when the well was cooled down, was cold, that happened. Okay, so be careful with annular pressure management. This is very dangerous issue, and we have 3 problems on that. Okay, let's talk about risks. So you have the information required for evaluating risks is monitoring the wells. You need to monitor the wells. You need to know what is the critical equipment. You need the functionality test for that. You do a risk evaluation per well. Then you do a ranking and mitigation plan. How do you manage that? You have, the company has a risk matrix, right? You have the well risk ranking, and you have well by well analysis and see what kind of costs, if you can identify that, if this is producing or not, shooting at the moment, if this is a production well. So then you have different actions. Rig workover, this is a high risk well. Then you say, it's high risk, but I will try to do a tuning patch. Then other well that is a rig workover. In order that the downhole festival say, maybe we can run an insert well. Okay, so, and also do troubleshooting. So there are many, if you need to identify the risk condition and see what you can do. Then when you do this, all you move is all the risk, you move down the risk. So then you know exactly what you have in your, how do you say, well, stock in your field, okay? This is a process that you need to follow in any field nowadays. Also, you can make, this is an example, you can manage different risks and manageability of the problem. So you can have areas or wells. For example, you can say well intervention for us is difficult or is not difficult. The storm shock, maybe you need you have a storm shock, you have sent, let's say, carbon steel, wells completed on carbon steel, and those are very high risk. When you have CO2, I work in a field like that. Or annular management, you can move this in a different position depending how do you manage the annulus pressures. What are the conditions of the trees, the downhole safety valves, and the completions. So you can have a very nice, or the well integrity normally working with the different departments. You can have identify what kind of risk in general, and also you have the matrix, okay? So what is the different operations we have? We have drilling and completion, sorry for the C, production operations, intervention, suspension, and on. Through those operations, what happens if you have loss of hydrocarbons content? You will have impact to environment, people, production, and financial. Be careful with that. So all those, let's say, designs, procedures, standards, and things that we are talking about today on the process are the things that we need to work as a company to prevent problems, okay? So that's the target, okay? Bueno, that's the presentation that I have for today, but I would like to mention that we have other seminars. This seminar was an hour. We have also some seminars focused to the drilling, focused to drilling and completions and production, well interventions, or production operations. All those seminars will have the duration depending on the time and the availability from your company. We can have from 4 hours to 8 hours each, where I speak in more detail what consideration for design and for designing the casing, the tubing, the cementing operation, the wells. So I have a clear agenda for each specific subject, okay? So I am open to questions if there are any questions today.
Yes, thank you, Santiago. The first question we have is, what's the difference between well integrity and wellbore stability?
Okay, wellbore stability, when we mention about wellbore stability, is the problems that, all the problems you have when you are drilling the well. Wellbore stability is you are drilling the well and you have an unstable formation, and the formation comes into the well and you start having problems drilling or cleaning the well up. That's an issue from drilling. And well integrity is all those problems that you have as a consequence of different problems and issues during the construction or after the construction of the well or during the intervention. So well integrity is related to the whole well, and stable formation is a different issue, okay? It's related to drilling, yeah.
Okay. The next question is, who's responsible for preparing the WID?
The well integrity management system?
It said WID. I'm not sure.
Well integrity document. I imagine this is, if this is right, it's the well integrity document. Normally, this is prepared, as I mentioned here, and it's important to consider, it's prepared by the well integrity engineer, but that document should compile and be worked with the different teams, okay? My recommendation is, because of the strategy, let me show you something. Because of the strategy is between all the departments, there are different programs, you know. The integrity guy is responsible for collecting all those programs into one and include that in the well integrity management system, okay? So it's quite important. This is a work that, and this is a very good question, that needs to be worked out with all the departments, but it has to be focalized in the well integrity, let's say, a team leader or management, okay?
Okay. The next question, planning is a problem, but what exactly in the planning is the problem? Also, is not slurry design, spacer designs, layout part of the planning?
Mm-hmm. Yeah, talking about cement, yeah. Excuse me. When I talk about the planning, job planning, you know, when you are, let's say, I'm going to give an example. When you you drill the section, before you finish the section, you have the information related to the formation properties. You collect the water, right? You run the simulations in the lab with the water from the field, right? And then you run all the simulation and say the compressibility will be at 24 hours X amount, let's say 3,000 PSI, 2,000 PSI, whatever. So that planning, that's part of the job, let's say lab part. But you also you run a simulator to do the cementing operations. Let's say at X amount of barrels per minute at these conditions. So then you take that program, prepare the program, all the space and everything, and take it into the field. In the field, let's say the company man said, no, I cannot reach that pressure. I cannot do this at this rate. And you pump at different rate. Then you, let's say, bypass the spacers, or you are lack of cement, or you or don't pump. You see, so planning and execution are together, but the planning is considering the actual. All right, now you run that planning, and then just before the cementing operation, you need to check that the pumping rates are okay, the fluids and the amount of fluids that you are going to run. You know? So you need a high quality assurance before that, okay? Sometimes the people write the program, send it to the field. In the field, they do more or less what you plan, but not what you plan, okay? So it's a responsibility of the drilling engineer to go, I say, to go to the field and ensure what you do, what you plan is done. Maybe that answers your question.
Okay. The next question, is it acceptable to use storm choke to insert and lock open a failed SSV? Can it be considered a barrier?
Storm chokes, I mean, we use storm chokes in many wells within Colombia, okay? But we use those because we didn't have that option at the moment, and the well intervention was really expensive. We designed the storm choke. The storm choke should be capable. It's a safety critical equipment. But when you run, in other words, when you run a storm choke, you cannot consider that a storm choke as a barrier, okay? Because you don't know how long it's going to be good for that specific storm choke. Storm choke is a very tiny piece compared with a safety valve. So my recommendation, storm choke is not a full primary barrier. What is the other thing that you troubleshooting? And the insert valve? Insert valve, it could be okay. Insert valve is different than storm choke, because insert valve is you troubleshoot this tune retrieval safety valve. You put a permanent lockout system, so you have these and these areas. Then this lower and upper area is going to be like a waterline safety valve, okay? Because you are going to permanent lockout, open and communicate with a control line. So you will not have forever a tune retrieval. Now you have a waterline retrieval, and that's very reliable valve because it's the same waterline safety valve, okay? But the storm choke, I will not consider as a primary barrier, never. My recommendation.
Okay, so the next question is, some operators are concerned with regular bleed down of annuals pressures because of the possibility to make leak rates worse. Do you have any thoughts on this topic?
Good question. Yes, it is. The continuous bleed off pressure is very risky, because every time you bleed off some gas, you'll have some fluid going into the annulars, okay? So this is very, very risky, that operation. I mentioned in some instances under certain management exchange documents, very specific risk assessment, you may have, you can do that, but it's not a good practice. I will prefer to go and fix that annually pressure instead of doing that kind of risk operation, because, you know, different people is going to take the decisions on the pressures, okay? So be careful with that. Yeah, good, very good question, my friend.
Okay. Next question. Most well integrity issues arise out of poor cement jobs, bad cement. How can we ensure proper cement in bad hole conditions?
Bad hole conditions, that's a problem. Yeah, when you have so many different, I mean, let's say when you have an unstable well, very difficult. If this is a well that you cannot pump cement, one of the things that you can do is try to do your best according to the unstable formation, trying to manage. You cannot pump it, you don't have control on the borehole, all right? Once you have a good control on the stability, let's say, then you can pump the cement. But if you have that as a critical issue all the time, maybe one thing you can do is trying to do a second stage cement job sometimes. But always at the driller, I recommend to do a proper cement job from the beginning, you know? So you need to control the well or the well conditions before you pump cement. That's it. You cannot pump cement without a good pumping rates and then stable pumping rates. Okay, it shouldn't.
Okay.
Yeah.
All right. Worldwide, how do you see the wells that are prone to natural flow of gas, for example, in a well formation that is conventionally pumped for fluid extraction? Risk assessment should cover that situation, covering all the surface barriers.
Can you repeat me that? Sorry.
Sure. How do you see the wells that are prone to natural flow of gas, for example, in a well formation that is conventionally pumped for fluid extraction? And then I guess the next question, risk assessment should cover that situation considering all the surface barriers?
I mean, it's a gas well that, I mean, always you have to be very careful. You have sustained pressures, if I'm not wrong, that the question is about. So you have very high annular pressures, and you have to do a full risk assessment. Also, not only internally, you need to go in the A, B, and C annulus, because normally some companies, they don't run connections, premium connections in the production and the surface casing or intermediate casing. And this is too risky. When you have a leak into the annulus with gas, then you will have no non-premium connections. You could have high pressures in a surface and intermediate casing, and this is very dangerous.
Okay. The next question, is back pressure valve, BPV, considered a barrier? Yes,
it is a barrier, and this is being used. The back pressure valve and two-way check valve is used for nipple down equipment. But normally I recommend for doing the work or intervention, the two-way check valve, because I can monitor pressure. You have some pressure build up from the bottom, okay? Normally, I recommend the two-way check valve because I can monitor pressure, okay?
Okay. So I've got a question in this, and the person's wanting your comment on this case. It says, I have seen well recently that has very high pressure when the operator tried to bleed off the fluent is only gas and take a very long time to drop the pressure for a few bars. When I asked the wells team, they said it has annually communication.
If that's the scenario, I would say that you have a full communication with the reservoir. And also, when you have those problems, what you can do is just to run and do a pressure leak investigation instead of bleeding pressure, because every time you bleed it, that pressure is going to be, that annulus for sure is 100% now gas, because it's not bleeding, so it's producing basically, and it's a small tiny hole compared with the production side. So for sure, in that case scenario, you have a big problem in a reservoir communicated to that A annulus or B annulus or whatever. Okay, be careful.
Okay. At this point, Santiago, I don't have any other questions. Oh, wait a minute. Thank you very much for clarifying that. I do have another question that just came in. Comment, thank you for the valuable information. My question is, what is the likelihood of having a bad cement and a high gas condensate pressure?
Bad cement and a high condensate? Well, you got, it doesn't, I mean, you can have gas migration, through the cement. If this is in the production liner, we normally have in BP here, Colombia, gas condensate wells. So is do a proper cementing job. So you need to learn and standardize that cementing job. You may have some gas contamination into the cement, but not at all, not 100%. Okay. So normally it's to have a proper design for the formation that you are pumping the cement. So consider the pressures. Hydrostatic pressure of the cement should be higher than the formation pressure, not that much, but also that prevents to have any influx, gas influx, because we normally have gas condensate in Colombia, and we have problems also, but we have good cementing jobs also, okay? And I recommend for those scenarios, if you have liners, run a production liner top packer. just to prevent that. As a secondary barrier, we normally run the liners with the liner hanger and production liner top packer, okay?
Okay, another question came in. Are there software packages to calculate prob and consequence categories?
What kind of software for which, excuse me, what kind of software for cementing or for designing casing or liner? Or production casing, or tubing, sorry.
Let's see if they responded that.
I wrote that normally while he is asking or clarifying the question, softwares are pretty good. Always. The softwares are, and there are many softwares. Let's say WellCat, the Spread Check, and other programs, but always the software, you put the information and you are the guy who is really designing that. So.
Yeah, risk evaluation is what they responded with, Santiago.
Risk evaluation. You have the companies, your company has a risk matrix, okay? But the criteria, you set up the criteria. So, and normally I recommend also to have a multidisciplinary team to do those risk assessments. Not only a few people. Always keep people from other departments who challenge you to evaluate the risk, because sometimes you say, no, this is fine, and maybe it's not fine. And some people have another idea. So softwares are good also for this risk evaluation, but please include people from other departments that they understand the issues. Okay? That's my recommendations.
Okay. Next question. What is the advantage of ASV versus MSAS valve?
The annular safety valve. The annular safety valves have been used, but not in many fields. Okay? So you can use that annular safety valves. But you have really well integrity, you can manage with a tuning safety valve. Okay?
Okay. Is it important to have MSAS on active and non-active side, or just active side?
MS, sorry?
MSAS?
I mean, no, I don't understand MS. What is MS, sorry?
Let me see if they will respond here real quick.
Many people, BP has like more than 200 acronyms. So sometimes the acronyms call me. I know a few, but not all of them. We use for everything in BP.
Okay, let's see if they respond to that. Another question I have. It's very important to identify the leak area to take mitigation actions. Please share some leak detection techniques.
There are so many, I mean, not so many. There are some typical leak detection tools, but the leak has to be huge, Sometimes the best way to do it, depending on the criticality, is to run and test. Let's say through the tubing, you run let's say you have a leak in the tubing, you run a plug, test, then move up, test, and go on. Sometimes you can detect the leak with some sonic tools, but it's very difficult. So it depends on the leak point and how expensive it's going to be to pressure test. And maybe sometimes you can just pull the completion. Maybe if you do that, it's very expensive. So again, I'm going backwards, going to a high strong procedure and standard for running completion equipment. When you run the completion equipment and pressure test at the beginning, instead of trying to correct later on. Sometimes it's better to do a very high quality, high standard running the completion procedures, than covering the problem, because later on there are tiny leaks that could kill you, man. Okay?
Okay, back to the
MS.
Yes, MS is Master Surface Analyst Safety Valve. So the question was, is it important to have a Master Surface Analyst Safety Valve on active and non-active side, or just active side?
In what kind of well? This is a very specific question. You need to have active if you expect pressures. Maybe this is a subsea well or not?
let's see here.
I will have an active, you know, because
gas lift well.
Right. In a gas lift well, you should have people all the times, right? Because you have a certain pressure, the valve operates itself, okay? But normally you manage the injection pressure, right? And you control the injection pressure at surface. So you should have a bleed off pressure mechanism at surface before anytime, let's say you have 800 psi in the annulus setup, so you have 800 or 900 psi, then you stop the injection. That's normally that you manage the gas lift system. Okay. So always you need a pressure relief valve at the surface, automatic injection pressure. Okay.
Okay. They said thank you very much.
Okay.
That's all the questions I have at this moment. Unless somebody wants to chime in.
I really appreciate when you have many questions. I really like it, and I will be very open to answer. And we are very open to extend or expand more into details on the cementing and completion design issues and production side, annual management. We can go for that in the future. I really appreciate your questions, all you guys. Thank you very much for your time.
Thank you very much for joining, and this will conclude the session, and we will send out links to everybody that joined if they would like to go back and review.